Hi, good evening, everyone. Am I audible?
Yes, ma'am.
Okay. Let's wait for 2 more minutes for others to join, then we'll start. You can all see the problems on your portal, right? Live coding week 3.
Yes, ma'am.
Okay. Okay. Is my screen visible to you?
Yes, ma'am.
Okay. Let's start with the first problem. So this week problems are mainly based on your linked list and stack and queue. Right. Okay. So I hope the concepts are clear for everyone, right? About what is a linked list, how it works, singly, doubly linked list.
Ma'am, for me it is not actually. It's like I understand the basic, but when we go into doubly linked list,
Okay,
right?
okay. No
Like,
issue. I'll
yeah.
explain that. Okay. So see the first problem. So first of all, let me give a brief overview of what is a linked list. So it's a data structure, right? It's a dynamic data structure. Means you can always add new nodes to it. And it is not stored in continuous memory locations. So the linked list nodes can be stored anywhere in the memory, but they're still linked together, right? So every node has a data part and a pointer part. And the pointer part will always point to the next node. So when we reach the last node of a linked list, obviously there is no other node after that. So the last node will have none or a null value in place of the pointer part, right?
Yes.
So what happens in singly linked list is that you can traverse in one way because the pointer points in one direction only. So the head will point to the first node, then first node to second node to third node, like this till the last node. But when we go for doubly linked list, then every node has two pointers associated with it. That means any internal node will have a previous pointer and a next pointer. So the previous pointer will point to the node before it, and the next pointer will, as usual, point to the node after it. So again, by definition, the head node will definitely not have any other node before it. So the previous pointer will be null for that. And for the
Hmm.
last node also, since there is no other node after it, the next pointer will be null. So in case of doubly linked list, we can traverse both ways. We can go from head to tail or from tail to head.
Okay. Okay.
Okay. So now
Then
see,
how delete works and insert works in that case?
yes, we'll see. Okay, we have a doubly linked list here also. So when we insert in a doubly linked list, when you want to insert a new node, then you have to update a lot of pointers, right? Because every node
Yes.
itself has two pointers. So I will show that when we do that example. It's the next question only.
Okay.
Okay. Okay. So this one is a pretty simple question, and this is also important for OP. So here you can see that we have the implementation of a linked list where each node is created using the given class node. So every node is an object of class node, right? So the linked list obviously has a head. So the head variable contains the reference to the first node, right? So head contains nothing but the address of the first node, or it is pointing to the first node of the linked list. Now you are given an non-empty linked list with n nodes, where these nodes are sorted in ascending order of their value. So your task is to remove nodes with duplicate values from the given list. So we can see that the linked list is ascending order sorted, right? Like this is a sample input, so it is increasing only, right? So 1, 2, 3, 4, 5, 6, 5, 7, 9, but there are many duplicates in between. So our job is to just remove these duplicates and have all unique values, but in the same order. The order should be preserved. So we have to write the remove duplicate function where it takes head as the parameter. So head is what? Reference to the first node of the sorted linked list. So this function should ideally remove the nodes with duplicates values from the linked list. And function does not need to return anything, right? You just need to remove the duplicates. All the other code is written. You just have to write this remove duplicate function. Okay. So this does not need to return any value, just remove duplicates. So is the problem statement clear for everyone? Anyone who did not understand problem statement?
So we need to first of all, means if we are removing, right, first we have to find that particular duplicates, right, and then
See,
we need to remove
the
it.
approach to doing this problem is that you have to compare every two nodes, right? So we have to
Every
compare the data part of every node with the next node.
okay,
So
okay.
as soon as we find a match, we will just update the link part. Let's say, for example, in the sample input, the first node is 1, right?
Hmm.
Second node is also 1, so data part matches. That
Yes.
means these are duplicate nodes. So I will keep the first node and I want to remove the second one. So
Hmm.
what I'll do is just update the pointer of the first node. So instead of now pointing to this second node, it will point to the third node, which contains 2. So now the second one is out of the linked list. The link is broken.
Ma'am, here do we require a loop, because how we are going to ensure
Yeah, of
that?
course, you have to do that. You have to traverse through all of the elements, right? So we'll use a while loop.
Okay.
Okay. So that's the approach. That is, we are going to break the link of every duplicate node and get it out of the linked list. So only the first occurrence of every number should be there. Okay, so let's start. So the suffix code is hidden here. Prefix code is hidden here. We just need to write the remove duplicate function. Let me know if the font size is big enough for you. Can you read?
Yes, ma'am.
Yes,
Okay.
ma'am.
Okay, so remove duplicate. And what are we taking as our parameter? Head. That is the pointer to the
Great.
first node of the linked list. Okay. Now see, we are going to take a temporary variable. Okay, let's call it temp1. Inside temp1, I'm storing head. That means now temp1 is also storing the pointer to the first node of the linked list. Okay. And in temp2, another temporary variable, I'm going to store head.next. So if head is pointing to the first node of the linked list, what is head.next?
The first element, the second element.
The second element, address of the second element or pointer to the second element. So temp1 now points to the first element, temp2 now points to the second element. So you see why we took these two nodes, because these are the first two nodes we will compare. This is the start of the comparison, right? So now we'll start our while loop. So how long will the while loop run? As long as we have reached the end of the linked list, right? And how to know that we have reached the end of the linked list?
None, ma'am.
Check it
None.
that
Right.
there is
So the
none.
next pointer will be none, right? So we can say as long as temp2 is not equal to none. Till then we will run this while loop. Now why temp2? We'll see how we are going to update temp1 and temp2. Okay. So the idea is, first we are going to compare the data of temp1 and temp2 and see if it is exactly equal. So for the first iteration of the while loop, this is the first and second element of the linked list. So you have to run an if block here. So if temp1 dot data is exactly equal to temp2 dot data. That means what I have to do now, if I found a duplicate, the first occurrence has
Remove
to
it.
stay.
Unlink that particular node.
So which one will be unlinked, temp1 or temp2?
temp1 dot
No, ma'am. Temp2 should be removed, right?
Temp should be
Temp2
removed.
should be removed because temp2 is the second occurrence. Temp1 is first node, temp2 is second node, right, in the first iteration. If there is a match, so we are going to keep the first occurrence, that is
temp
temp1.
temp1 dot next is equal
Temp1 dot
to
next. Yes, that we can.
temp2 dot next.
Okay, see.
Dot next or double next.
First we have to preserve some things, right? So if I directly remove temp2, then I won't have the temp2 dot next pointer. So let's first preserve that pointer, which is pointing to the third node. Right. So currently, if I find a match, first thing I'll do is preserve the temp2 pointer, that is temp2 dot next. So now in temp2 variable, I'm going to store temp2 dot next. Right. This is the pointer to the third node. Now I can unlink. So now I want my first node to point directly to the third node. So can I write temp1 dot next, that is first node link part, should now be pointing to temp2, which is the third node.
I'm not
Yes, ma'am.
getting this part. I'm not getting this part. How it is third node? Because head dot next is 3.
See,
Third.
first look at the first iteration. What is temp1 head? Head is pointing to first node, that is 1,
First
right?
node. Yes. Yes.
Temp2 is head dot next, that is second node, which is again 1, right?
Okay.
First two nodes. Now we are running the while loop until temp2 becomes none, right? That is until we reach the last node. Now first comparison I'm doing, this is first iteration of while loop. Temp1 dot data is exactly equal to temp2 dot data. So that is I'm comparing first two nodes. So they're
Okay.
equal, right? That means I have a duplicate and I am going to preserve the first occurrence of every number. So obviously temp2 has to go. Right, but if I directly want to deallocate this node, then I will be also losing the pointer to the third node, right? Because second node is pointing to third node.
Yes.
So I
Okay.
have to preserve the temp2 dot next pointer. So if I find a match, I am going to preserve temp2 dot next as the new temp2. Right, now this third node, this 2, is now becoming your second node, right?
Okay.
So you preserve that pointer, and now temp1 dot next, that is the first one. The pointer part of this first node will now point to this 2, which is temp2.
Okay. Okay, ma'am. Understood. So at this point, temp2 is equal to temp2 dot next actually points to the third node.
Third
So
node.
that's what we are
Yeah,
referencing.
so before you unlink temp2 like that, you have to first preserve the pointer, right?
Okay.
Now what happens if I don't find a match? So if temp1, temp2 data is different, for example, now if I do the comparison between 1 and 2, that is different data. That means I don't need to do anything, I can move on to the next pair of nodes, right? So else part,
Ma'am, this here in the above two statements, you can say temp1 dot next is equal to temp2 dot next, no? Because
no.
these two statements
Temp,
are same.
temp1 dot next. What is temp2 currently? Which node is it pointing to?
Temp2 is
To the third node, this 2, right? So what is temp2 dot next? The fourth node.
okay.
Okay, so temp1 dot next should now point to the third node. The second node is omitted because of the duplicate.
No,
Ma'am,
ma'am.
how did fourth node come, ma'am? Sorry for interrupting. How
No,
did fourth node come?
fourth node is not coming. He is saying that
Okay,
if
okay,
I
okay.
now store temp1 dot next equals to temp2 dot next, then it's the fourth node. Okay, but temp1 dot next is pointing to temp2, which is the third node.
No, ma'am. When you say temp2, if you look at the third statement, temp2 is equal to head dot next. So that means temp2 is
Second node.
pointing to second node,
Yes.
right? So when you compare this to the both are matching. So what you are saying is temp1 dot next. I mean, my proposal is temp1 dot next is equal to temp2 dot next. That means temp2 dot next
But
has
I
a
have already changed temp2 before that, right? Temp2 equals to temp2 dot next. Here I have already changed the temp2 pointer. So now temp2 is no longer pointing to the second node, it is pointing to the third node.
Ma'am, if you remove that line, so then
So then
We have to preserve, right?
we have to preserve the pointer, right? How else will you get the third node pointer? It is only present in the second node, which you're attempting to remove.
Ma'am, we are preserving because we can't jump directly to the third
No.
point in a link, right?
In a linked list, every node has the pointer to just its next node. That's the way it's linked, right? So if I randomly remove any node, I won't be able to find the pointer for the next node without preserving it. Okay, see, 1 points to 1, then this second one points to 2, then second, this first 2 points to the second 2, like this. So I am trying to remove this second 1, right? So now the first one has to point to 2. That's the pointer I'm trying to create. Look, first two nodes are being compared, both are 1 1. Okay, since they're equal, so now I know that temp2 has to be updated with what? With the pointer to the third node, because now the second node will be removed since it's a duplicate. So temp2 dot next, just tell me at this point in this line 6, what is temp2 dot next?
temp2 dot next is actually pointing to the third node.
That is
Has
the
a
node
pointer.
containing 2, right? The node containing 2.
No, ma'am, it's a third node. Temp2 dot next has a pointer which is pointing to the third node in the list.
Third node, and it contains what?
2. Second index, 0, 1, 2. Third.
Yes, and it contains the value 2, right? The data part is 2.
2.
That's what given in the sample input.
Correct,
1 1 2 2.
Correct.
Right. So this temp2 dot next is actually the pointer to this third node, which is what we are trying to preserve. So now your temp2 contains the pointer to third node. which is now stored in the temp1.next, so that your first node now directly points to the third node and the second node is removed as a duplicate.
Ma'am, for the nodes, right? You
Oh,
can
okay,
just
okay.
add a comment, right? Means like which node is pointing, like temp1 dot
See, that
temp2
that
is
is
equal
what
to.
you can do when you do a dry run, because this thing is a loop, right? So the temp1, temp2 data is changing every iteration. So if you want to do a dry run, then you can obviously comment and check that you can make
Also,
a table out of it.
this temp1 is equal to head that we have written, right? So
Hmm.
can we write there head dot data? Because I can see that
No,
in
that is
class
not a
node.
pointer. That is
Okay.
not a pointer. Head.data is just the data part. It will just fetch this value 1, not the pointer. The node itself, this is the address. Head is the address. See,
Okay.
head is a reference to the first node, right?
Uh-huh. Okay,
Okay,
here is
after
the
this,
address,
yes,
and then head dot next is the data part.
no. If head is the address to the first node, right? So head points to first node. So what is head.next? The pointer of the first node, that is the pointer to the second node.
Mm-hmm.
Okay, that's it. And when you write head.data or temp1.data, temp2.data, that is the data part. That is not the reference.
Okay.
See, that's
But
why just look at the node class, right? So every node has a data part and a next part. Data
mm-hmm.
part is just the data, and this next part is the pointer to the next node.
Yes.
Ma'am, data is data type, right? Or the value?
Data, the value.
Okay, okay, okay.
Okay. What is stored in the node? So every node has two parts, data and link part. Okay. So up to this, is it clear? This line 7, up to line 7, is it clear for everyone?
Yes, ma'am.
Now you tell me, if temp1 and temp2 data did not match, then what do I have to do? So let's say, for example, if it was 1 and 2, it did not match. So now next I have to compare what? The second and the third node.
2 and 3,
Right.
ma'am.
2 and
So
3.
I compared nodes 1 and 2, didn't match. So now I'll compare 2 and 3. So how do I update the pointers for that? That means
Uh,
now temp1 should store what?
Third value, temp1 dot next.
Or I can just write temp2.
Yeah, temp2 dot next.
See, in temp1, now I want the second node. Second node is stored where? Temp2. Assume that, see, in the sample input, just assume that it is 1, 2 in the beginning. First two nodes are 1, 2. Fine. So now temp1 is containing the node 1, temp2 is containing the node 2. Data did not match, so I'll come to the else part. So now I need to point temp1 to the second node and temp2 to the third node. So can I not store temp2 directly in temp1? Since this part didn't happen, right? The if block didn't execute. So currently temp2 is storing second node, temp1 is storing first node. So I want to compare second and third. So temp1 can now store second node and temp2 can store the third node, which is, where is the link to the third node?
Temp2 dot next.
Temp2 dot next.
Yeah.
Right, so I updated both the pointers. Now temp1 points to second node, temp2 points to third node. Is it clear?
Yes, ma'am.
So like this way, we are going to compare every two nodes, every two corresponding nodes. And every time you find a duplicate, you know now how to bypass that connection. Right. So that's
Ma'am, in the lecture, sir has given something complex for head part. Like while operating near head part, we should not directly unlink or link
no,
any.
that is when head contains the data. Okay. In some cases, head itself might be the first node. In this case, head is not a node. In this case, head is just a pointer. But we'll see in the next problem only, head will be treated as a node. In that case, we cannot directly do this.
Okay, ma'am. Okay.
Okay, so that will be mentioned in the question, whether head is a node or a reference. Okay, so any doubt in this code?
Can you from the start again?
See, I'll say it again. Temp1 is the first node. Okay, temp1 is containing head, which is a reference to first node. Temp2
Yes.
is containing head.next, which is reference to second node.
Okay.
Okay. So we are running the while loop until temp2 becomes none.
Ma'am,
That
here
means
this reference that you're talking about, it is actually the value to the second node, right?
No, it's not the value, it's the reference. Temp2. See, temp2 is storing what? Temp2 dot next. So at some point it's going to become none when I reach the end, right? So that point will stop the while loop. So now we have traversed the entire linked list. Okay. Now inside the while loop, I will check if temp1 data is equal to temp2 data. That is, if we find a match, then we are preserving temp1 and removing temp2. Okay, think of it like this. First occurrence is preserved, second occurrence is removed.
Okay.
So how to remove second occurrence? I have to first preserve the pointer to the third node now, which is at present at temp2 dot next. So now temp2 contains temp2 dot next. So now temp2 is a pointer to the third node. And now I have to link first node to third node to bypass that first second node link. So temp1 dot next was previously containing pointer to second node. Now it will contain pointer to third node, which is stored in temp2. The second node is bypassed completely. Okay, and if you do not find a match, then you simply update the pointers. So temp1 was containing reference to first node, temp2 was containing reference to second node. So now temp1 will be updated to reference to second node, temp2 will be updated to reference to third node. So temp1 contains temp2 and temp2.next is reference to third node, which is stored in temp2 now. Okay, so next iteration when you go, this temp1.data is the second node data, temp2.data is the third node data. Clear for everyone? Okay, let's run this and see. Okay, all our test cases are passing. So we can submit. This is the simplest one, right? Now we are going to do it a bit more complicated. Sure, right? I can move on to the next one. Any other question you have from here?
1 second.
Okay. All right, now see, this question is a bit more complicated than the last one. Not complicated, the operation we are trying to perform is very simple. Okay, so earlier we were trying to remove duplicates in a singly linked list, that is one-way reference. Now we have a doubly linked list. Like I said, every node now has two pointers, previous and next. So every node points to the previous node also, to the next node also, in two separate pointers, and it has the data part obviously. So obviously the first node will not have any node that is previous to it, right? It is the first node. So the previous pointer for first node will contain none. And similarly in the last node, there is no node after it. So the next pointer in the last node will contain none. Right? You can see in the example, this is the structure. Okay. So what we are trying to do here is we need to write a procedure called, or a function called, insert at pause. And this will take two parameters, a data and a position. Okay, so it will accept an integer data which I need to insert into the given linked list at a given position, which is stored in this pause variable, where the position has to range between 1 and the length of the list. That means it cannot be equal to 1. That is, I am not trying to insert in the first node. So it has to be greater than 1. The position of the first node is 1, second node is 2, third node is 3, like this. Okay, position starts from 1. So obviously the position that I get to enter the data at has to be greater than 1 and less than equal to length of the list. That means I can enter a new data anywhere in the list except for the first node. So that's the function we need to write, insert at pause. Two parameters, the data itself that you need to enter and the position where you need to enter the data.
My position always starts with 1. That's what you said, right?
Yes.
Okay.
Here we are starting position with 1. First node is position 1.
Okay.
Okay. So you can see the class node now, in the previous question you saw it had self.data, self.next. So it now again has a third pointer, self.prev, second pointer, I'm sorry. So this is for the previous pointer, since this is a doubly linked list. So every node has three parts, data and two pointers, one for previous, one for next. Okay, now we'll have two other pointers, okay, which is the head pointer and the last pointer. So you saw in the previous question, head was pointing to the first node, right? Here also head points to the first node and last points to the last node. So why we have this last pointer? So that we can also, if we want, we can also start traversing the linked list from last to first, that is tail to head, right? So we have a pointer to the last node and then we can use the previous pointers to come till the first node where the previous pointer is null. Okay. So two extra pointers, head and last, head pointing to first node, last pointing to last node. So you can see the sample input. If I have this linked list 1, 3, 5, 7, 9, right? So 1 is position 1, 3 is position 2, 5 is position 3, like this. Now we want to enter data 20 at position 2. That means the answer after I have ran the program, it should look like 1, 20, that is position 2 is updated to 20, then 3, 5, 7, 9, right? That means all of the other elements of the linked list have shifted one place. And also we are going to be traversing this in both ways, so forward to backward, backward to forward, but we don't have to do that. We just need to write this single function, insert at pause. All the other code is already there. Okay, so you can see the prefix code is visible to you. The suffix code is hidden, right? The suffix code is to take the input and also to traverse. That is, we can go from head to tail or from tail to head. So that's the hidden code. Let's write the solution. So before we start writing, you tell me what can be the approach for this. So if I say I want to enter at node 2, so here I have this example, right? First node contains 10, second node contains 20, third node contains 30. Let's say I want to enter 15 in position 2. So which pointers will I have to update?
Ma'am, we need to make a relation between previous pointer and the node pointer and the next pointer.
So I will tell you all of the updates, okay? And if I miss something or I say something wrong, you correct me. So first thing is I need to enter at the second position. That is the node where now 20 is present. Here I want 15, new node. So first I have to update. I have to preserve which one? I have to preserve the pointer for this first node dot next, right? This pointer I need to preserve. Because now 15 will point to 20. 10 will point to 15. So which pointers will be updated? 10 will point to new node, right? And the previous part of the new node will point to 10. Next part of the new node will point to 20. And previous part of the 20 node will point to the new node. Is this correct? 4 updates.
Can't we just break the connection between the first node and second node and insert a node and then
That's what we are essentially doing. We are breaking the connection, but you need to preserve the pointers. Otherwise, you don't have the address for the nodes. They are not continuously
we can preserve
stored.
the first pointer to the next, right? This node.
Yeah, that's what we are going to do. The first pointer, the first node dot next, that will be preserved.
Preserved, okay.
Okay, and again, this one, this 20 node, this pointer has to be also updated. The previous part of the 20 node was previously pointing to 10. Now there will be a new node. It has to point to that.
50. Yes, it will point to previous, again a previous node. Too.
Yes. So there will be a total of around 4 updates. Okay. So the process is clear how to do it at any position, right? Let's start writing. It will become clear. So def insert at pause. It will take self, obviously. That is the object, the data, and the position. Okay. Nothing else I need. Now first I need to create the new node. New node will contain what? What is the data? Where is it stored? The data of the new node? In this data variable?
In data variable, ma'am.
Data variable, right? So I will write new node. I have to call which class?
Node class.
Node class.
So this is an object of node class, and what will be the parameter? Data.
Self comment. Okay.
Okay, just data. So this creates a new node. Now see, every time a new node is created, obviously the init function is called, right? So the data now contains whatever data I passed in the function, and there are now 2 pointers, next and previous, which are both currently none, not pointing to anything. Just a single node has been created. Now next part is very easy. We just have to make the connections in the right place. So now let us take another variable called C. Okay, this is sort of like a counter. We'll see why this will be essential. And let's take a temporary variable where I'm going to store the head node, okay, or the head pointer. So that is self.head. Okay, now the main thing is I need to run a while loop. Till where will I run? See, I know the position where I want to insert. Now I need to start making updates from the position before that, right? So if I want to enter at position 2, I need to start making updates from position 1, right?
So
So
pos minus
I
2.
will pos minus 1. I will run the while loop as long as c remains less than pos minus 1. Okay, now inside the while loop, what happens? So I will just update the pointer of temp. Okay, I'll just update the pointer of temp as long as it takes me to reach that position where c is no longer less than pos minus 1. So here I can write temp is equal to temp dot next. That is, I'm just traversing the linked list, nothing else. And every time I have to update the counter also. So for example, let's say if my position where I want to insert the data is 2. Okay, C starts with 1. How many times will the while loop run? Will it run even once? My position is 2.
Which
Where I
position
want to
you
enter.
Yeah, one C.
Pos is 2. Okay.
No, it doesn't run even once because
That
2
means
minus
the
1 is.
correct.
Right.
So 1 is not less than 1, so while loop condition fails. Okay. Now, okay, let's take a different example then. If my position is 3, in that case, how many times will the while loop run?
2.
Once.
Once. That means for when c is 1, only then the while loop will run. So what will happen? Let's take, for example, in this one, I have 10 as the first node, 20 as the second node. So I want to insert here at 30. Okay. So c is initially 1. C will run until it is less than pos minus 1, which is 2, if pos is 3. So temp is pointing to the first node, right? Initially temp has stored what? Head, which is reference to first node. So initially temp is pointing to first node. So in that first iteration, where is temp updated? Now where does temp point? In this iteration, when 1 is less than 2. Okay.
Second
Now temp
position.
is updated. So now
Second.
temp is
Second
pointing
position.
to second node. That is this 20 node, right?
Yeah.
And C is now 2. So no more iterations are possible. So now that means I have reached the place, right? After this node, currently wherever temp is pointing, after that node, I have to insert the new node. Correct? Now we are just going to do the pointer changes. So first thing I need to do, we'll take a new pointer called temp1. In temp1, so what did I say? First, what do I need to preserve? If I want to enter a new data at position 3, that means in place of this 30 node. So I need to preserve which pointer? This 20 to 30 link, right? This is the address of the 30 node. I need to preserve that. So currently, my temp is pointing to which node? Second node, containing 20, right? So can I say that temp.next is the address of the third node?
Yes, we
30.
can say that.
So in temp1, let me preserve this pointer, temp.next. So now the pointer from 20 to 30 is preserved. Okay. Next, I will now change the pointers for new node. So now this temp, which is still pointing to the second node. So now second node has to point to the new node, right? So temp
Yes.
dot next should now point to new node.
That we created earlier.
Yes, that we created. So now new node has been inserted in the third position, but still many pointers have to be updated. So now new node has how many pointers? 2, previous and next, right?
Again 2.
So the new node dot next pointer should point to which node now? This 30 node,
Temp.
30 previous.
right? So where is the address for this 30 node stored? In temp1.
Temp 1.
So I will write new node dot next is going to point to temp1. But new node dot previous, that address also we need. That is the pointer to the second node. So who is still pointing to the second node? Temp.
Temp.
So I will write new node dot prev is temp. So now the new node connections have been established, but we still need to update temp dot next. Okay. So here,
When temp dot next.
okay, temp dot next we have already updated. Yes.
Yes,
So now we just need to update temp1 dot previous, right? So temp1 is the one pointing to this 30, right? Temp dot next. The pointer for this 30 nodes previous part has to be updated. It has to point to what? The new node.
New node.
So I will write temp1 dot previous is new node.
So in essence, like temp1 stores the third node, and
Temp1 stores address to third node. Yes.
address to third node, and temp stores the address to second node.
Second node. That's where the while loop stopped, right? So temp hasn't been updated. Temp is still pointing to second node.
And we are traversing till the k-1 value, so that
Yes.
at the kth position we can insert it, and that's why
Right.
we are breaking it in between. So this
Right.
is how the break happens. So,
Okay, but first you need to preserve the pointer from second to third node. Yes, this pointer will be lost once we update.
okay.
Okay, let me run this once before I take other doubts. Okay, something is wrong. Here I think we missed one update. So the temp dot next to point to the new node. One second, just let me try this and see. Okay, then I'll explain.
Ma'am, can you show the error?
The error I'll show you. One second. Okay, so the error is where at line, let's keep it like this. Expected output is this. The actual output where I'm getting the error is inserted pause. Okay, doubly linked list has no object, has no attribute inserted pause. Attribute error. Okay, so that is probably because of the function call this is happening.
I think functions.
So actual output here, let me check once. This code is correct, nothing has to be changed here. There is some kind of
indentation problem.
indentation problem. Yeah. Which part is it? This now?
Ma'am, this
Okay.
function need to be under this.
Right, it has to be under the doubly linked list class. Okay. Let's just copy paste.
One more space, ma'am. One more space.
Okay. Okay, so all the pointers are, I think, correct only. Let's run again. Okay. Okay, so any doubt here in the pointer update part? So first we preserve the pointer from the k-1th node to the current kth node, right? And then we do all the updates. That is the one pointer that can go missing if you break the link first. Okay, should we go to the third question? Any other doubts you have? Okay. So this is the last linked list question. You have all done merge sort, right? Merge sort, everyone is familiar with?
Yes, ma'am.
Yeah, ma'am.
What is the timing complexity?
N log n.
N log n.
N log n. So what does merge sort actually do? What type of an algorithm is it?
It divides and conquers, and it creates a new list to sort things.
To have the merged sorted list, right?
Yes.
Okay. So it is a divide and conquer algorithm, good time complexity. So that same thing we are going to do here now using linked lists. So here now we have to merge two sorted linked lists, right? So we have again the node class. Every node has two parts, data and pointer part. So you have to consider here the implementation of a linked list is given where each node is created using given class node. Head is a variable that contains reference to the first node. So head is again just a reference. Now you are given two non-empty lists, n and m. Okay, one contains n nodes, one contains m nodes. So where these nodes are sorted in ascending order of their value, that means the lists themselves are sorted. Your task is to merge these two sorted lists into one sorted linked list. Okay, so we have to write a function merge sorted list head one.
Your voice,
Sorry,
it's not clear actually.
my voice is not clear.
No, it's clear.
Okay. Okay, so we have two lists, right? We have a list with n nodes, we have a list with m nodes. What is my task? I need to merge these two sorted lists into one sorted linked list. Okay. Now we will write a function called merge sorted list, which takes two pointers, head1 and head2. Head1 points to the first node of the first list, head2 points to the first node of the second list. Okay. Function should return what? Reference to the first node of the merge sorted linked list. That is the new linked list that we are creating. This function should only return the reference to the first node of that. That is the head node. That's all it should return. So if I have two nodes, two lists like this, 1, 3, 5, 7, 9, 11 is the first list, 2, 4, 6 second list. Okay, these are two linked lists which are already sorted. Now I merged these two and this is the new merge sorted linked list, and I just need to return the pointer to the head node of this new list. Problem statement is clear?
We have to create a new link list, ma'am, in this.
New linked list, yes.
Okay.
By merging them and then return the pointer to the first one, right?
Right. So here now, what is the approach? How should I merge these two? How do we usually merge in merge sort? We compare all the elements one by one, right? We compare two elements and then we pick the smaller one to insert first. So that same logic applies here. So head 1 is pointing to first node of first list, head 2 is pointing to first node of second list. So I will first compare these two nodes. So which one is smaller?
And one question.
Hmm.
We need to merge this linked list into a linked list now.
Yeah, in a linked list only, the merged sorted linked list.
No, I mean it should be in a single linked list now.
Yeah, single linked list. See, these are two separate linked lists. I want to merge them into a single sorted linked list. Okay, so first comparison will start with the first element of first list and then with the first element of second list. Now, which one will I pick?
First element of the first list.
Yes, that's the smaller one, right? So that will first be entered into the new linked list. Okay, and the head node will point to this. That head pointer only I have to return after I have completed merging both the lists. So now here also all the prefix suffix code, those are hidden. We just have to write this merge sorted list function. Okay, now here also the main thing is the pointer update. Okay, once the pointer update part is clear to you, you can very easily write this code. So see what happens. We'll explain as we go. So def merge sorted list takes two pointers, head 1 and head 2. Okay, so first in temporary variable 1, temp1, I will store this pointer head 1, and in temporary variable 2, let's store head 2. Then I'll create two more variables, head 3. This is what? This is going to contain reference to the first node of the new list that we are creating. So initially head 3 contains none because it hasn't been created yet, the linked list.
Ma'am, head 1 and head 2 are nodes or pointers?
Pointers, references.
To what? First
To
and
the
second?
first node of each of the lists. Head 1 points to the first node of first list, head 2 points to the first node of second list.
Okay.
Now head 3 is going to point to the first node of the merge sorted list that we are creating. So initially it is none, since now till now none of the nodes have been created. And we'll also take temp 3. which is also going to be none. We'll see why we need these two. Okay. So now we need to run a while loop. Now you tell me, when I'm comparing these two lists, at some point I have to stop the comparison. What is going to be that point? Till how long will I run?
Any of the linked list
Any
which
of
you
them.
can manage.
Until any of the linked lists gets exhausted.
None.
That we traverse the entire list. Any of them. That means the smaller list obviously will get exhausted first, most of the time.
Yes.
Okay. So the while loop condition will be what? While temp1 is not none and temp2 is also not none. That is, as long as there are more elements in each of the lists. As soon as one of them gets exhausted, we are going to stop the while loop, right? Because then we can just, if one of the lists is exhausted, that means the rest of the elements present in the other list are already sorted. So we can just point to that. No need to compare anymore. Okay, now for the first iteration, let's see. Temp1 is pointing to which node? First node of first list. Temp2 is pointing to first node of second list. So what do we need to compare? The data part, right? So if statement will be what? If temp1 dot data.
Data is
So
less
we have
than.
to check which one is the smaller. So we'll check if temp1 dot data is less than temp2 dot data. If so, then we'll check if this is the first node we are creating in the new list, right? If the new list is currently empty, in that case we'll check if head3 is equal to none, that is there are no nodes currently present in the new list, then we have to create the head node. So now head3 will contain reference to which node? Temp1 or temp2? If temp1 is smaller,
Temp1.
temp1. This is the first node. Okay. Also, temp3 will now point to head3. Okay, so this is the temporary variable for the head reference of the new linked list. Now, in the else case, in case there are already nodes present in the new list we are creating, right? In that case, no need to update head. Temp is the pointer that traverses the third list. So in the else case, we will do temp3 dot next. Temp3 is pointing to where? The current node, right? The current node in the third list, the new list we are creating. So temp3 dot next is where I insert the next node. Yes or no? Look, take this example. Among these two, 1, 3, 5, 7, 9, 11 and 2, 4, 6. So first I compared head 1 and head 2, 1 and 2. Which one will get inserted?
One will get inserted. But ma'am,
One
you're not created the list. No, here there's no list has been new list has been created.
That means we are now going to create, right? We have the head 3 pointer. So head 3, at this point head 3 is none or not?
Yeah, head 3 is none.
None. That means this nested if is true. So now head 3 will point to where? Temp1. That is this node containing 1. So head 3 is pointing to temp1, right? And temp3 is pointing to where? Head 3. So temp3 is going to be the pointer to the pointer that we use to traverse the new linked list that we are creating, the merge list. Okay, now see in the next iteration. So since 1 and 2 have been compared and 1 has been inserted, so which pointer will move forward? Temp1 or temp2?
Temp1.
Temp1. So temp1 will now point to the next node, which is 3, right? The comparison now is between 2 and 3. Okay, so which one will be entered?
2.
2. So let me write this part, then I can take the example and explain. Okay, so basically this temp3 dot next will now point to whatever node you are trying to insert, temp1 in this case, and just I'll finish writing and I'll explain the whole thing. Temp3 is going to point to temp3 dot next. So we have to update the temp3 pointer also. In any case, even if the head node is none and you're creating the head node, or there are already nodes present and you're just updating temp3, in any case, temp1 has to be updated if temp1 data is the smaller one, right? The pointer of temp1 has to be updated. So that update will happen here. Temp1 is equal to temp1 dot next. Now this exact same thing has to repeat for temp2 also, in case temp2 data is the smaller data. So we'll write an else block. So again the same thing, we can just copy paste it if we want. Okay, so here what we have to change, if temp2 data is being inserted, just enter the temp2 here, and temp3 dot next will now contain temp2, and temp2 is equal to temp2 dot next. Okay, now I can explain. Okay, look, we'll take our sample input. Okay, so first 1 and 2 is compared. We see that temp1 data is the smaller one. At this point, head 3 is none. So head 3 now points to temp1 and temp3 points to head 3. Fine. Now which pointer is updating temp1 or temp2? In the first iteration, which pointer is updating, temp1 or temp2?
Temp1.
Temp1. So temp1 is equal to temp1 dot next. Right, this line 14. So now temp1 is pointing to node 3. In the next iteration, again check, is temp1 none? No. Is temp2 none? No. So there are elements present in both the lists. So we can continue comparison. Now compare temp1 dot data, that is 3, with temp2 dot data, that is 2. Which one is smaller? Temp1 or temp2?
Temp2.
Temp2.
Temp2. So come to the else part, this one. So now is head 3 none?
No.
Head 3 is already pointing to the previous temp1, that is node 1. So we'll come to the else part. That means there are already nodes in my third linked list now that we are creating. So temp3 at this point was pointing to where? Head 3, right? So now temp3 dot next is where I need to insert the next node, right? Temp3 was pointing to this first node 1, right? The head 3. So where will I insert this 2 now? Temp2 in temp3 dot next.
Yes, ma'am.
Temp3 dot next is now storing temp2. Again, you have to always update the temp3 pointer. So temp3 will now point to temp dot. Sorry, here it should be temp3 dot next. This also temp3 dot next. So why am I doing this update in line 21? Temp3 is equal to temp3 dot next. Because see, temp3 always needs to point to the last node in the new linked list, right? We entered another node in the new linked list, this temp2. So now temp3 needs to point to that node. Okay. To the pointer part of that node. So temp3 dot next was first updated with the new node, that is temp2, and temp3 is now updated with temp3 dot next. That is whatever comes after this. So do you need me to do a dry run for this? Will that be easier to understand?
And if you don't mind, can you please just repeat how this with line 12 and line 20 works? Like template of next equals temp1, what exactly is?
Wait, let me just do a quick dry run for one, two of the iterations. It will become much clearer. Wait 1 minute. Okay, can you see my entire screen? This PDF is visible too, blank one.
Yes.
So let's do a quick dry run. Okay. My first list, let's call it L1, is containing 1, 3, 5, 7, 9, 11. Okay, and L2 is containing 2, 4, 6, 8. This is head 1 pointer, this is head 2 pointer. Okay, head 3 at the beginning is none, and so is temp 3. Both are none. So I am storing this head 1 pointer in temp 1 and the head 2 pointer in temp 2. Okay. Now this corresponded with the actual code. So what is the first thing I am doing? I am checking whether temp 1 and temp 2 are none or not. That means have I reached the end of any of the lists? First iteration, that condition is holding correctly. Both lists have elements. So now I am going to do the first iteration of the while loop. Now keep checking the code along with it. What is the first thing I'm doing? If temp1.data is less than temp2.data, that's what I'm checking first. So temp1.data is 1, temp2.data is 2. Right? Which one is smaller? Temp1. Okay. At this point, is head 3 none?
Yes.
Yes. So now head 3 should be pointing to which node?
Temp 1.
Temp 1. Next, see this. Temp 3 needs to also be updated. Temp 3 should now point to what? Head 3. So temp 3 is now pointing to head 3. Basically, these are the same reference. Head 3 is also pointing to temp 1 only. Temp 3 is also pointing to temp 1. Okay. Now, second iteration. But remember, before that, I need to update temp 1. So temp 1 will be now pointing to which node? Temp1.next, which is third node. This 3. Right. So temp1 is equal to temp1.next, since I have inserted one element from temp, the first list. So temp1, I'm sorry, not data. Next. So now before second iteration, this is temp1, this is still temp2. Okay. Are any of temp1 or temp2 none?
No.
No. There are more elements, so we can start comparing. So temp1 is less than temp2 or the other way around? Which one will be inserted, temp1 or temp2?
Temp 2.
Temp2 will be inserted. At this point, is head 3 none?
No.
No. So we'll go to the else part. What is the else part saying? If head 3 is not none, then we have to update temp3.next to temp2, and temp3 has to be updated again. So let's carefully see what is temp3.next. Temp3 is currently pointing to head 3, which is nothing but temp1. That is this one. So temp3.next. This is what? The place or the pointer to the new node that I'm inserting,
Temp 2.
which is temp2. And now temp3.next is containing the pointer to temp2. So now can I update temp3? Temp3 always has to point to the last node link part. So temp3 will now be temp3
Next.
dot next, which is where? So what is current temp3 now? Current temp3 is pointing to
2.
this. Okay, so this node dot next, that is your current temp3. Temp3 dot next, that is where you will insert the new one. Okay, the next one that comes along. So at this point, now since I entered from the second list, now which needs to be updated? Temp2. Temp2 is equal to temp2 dot next. Now third iteration.
Ma'am, here we are actually not creating a new list, but we are actually
No,
merging the two lists.
The two using pointers.
So basically, at end of this whole program, we will not be able to retain the original L1 and L2 because it will already been modified by this L3 or whatever, the new list, right? That's the understanding.
Yes.
Okay, thanks.
Yes. So the space used is same. Okay, no new space is allocated.
Yeah. But while starting of the session, when we discussed that we are creating a new list, so my understanding was that we are
new
creating
list means what? From these two, we are merging them into a new list, not assigning a space for a new list. Okay.
Okay.
Not like that. Just merging them into one single list.
Okay.
Okay. So current temp1 is pointing where? To 3. Current temp2 is pointing to 4. Right. Again, temp1, temp2, both are not none. So we'll continue with our comparison. So which one is smaller, temp1 or temp2? 3 or 4?
3. Temp1.
Okay.
Temp1.
Now see, now since we already have the head node, right? So obviously always we are going to go to the else part. The first part will only be true when we insert the first node or when we make the connection for the first node. This head 3 equals to none. That is only true once throughout all the iterations. Throughout all the other iterations, it is going to be always in the else part. So now I know which one is smaller, temp1 is smaller. So I have to insert temp1. So what will be that? Temp3 dot next is now going to store what?
Temp1.
Temp1. And again temp3 has to be updated. So temp3 equals to temp3 dot next. Okay. Now which temporary variable needs to be updated? Temp1 or temp2? Which one moves one place forward?
Temp1.
Temp1. Because I inserted one element from this list, so temp1 is equal to temp1 dot next. So like this, I will continue for all the elements. Should I do a few more runs or is it clear?
It's
Anyone
clear,
who
ma'am.
Okay. Everyone, right? Okay. So now, this is how we are going to sort both the lists and merge them. Now, what happens when this while loop exhausts? That is, one of the lists are exhausted. What happens then? In this particular example, the second list will be exhausted first, right? After that, what do I do?
Yes, the remaining list has to be connected to the final list.
Final list, right?
Yeah,
So here
links.
now, I can do this. Okay. I don't know that which one exhausted, right? So I first have to check if temp is not none. I'm sorry, temp1 is not equal to none. That means there are more elements in temp1, right? That linked list, the first linked list. In that case, where will I link? How will I link it? Temp3 dot next will now be storing temp1, and the rest of the elements can follow from this first linked list since they're already sorted. And if the second list contains more elements, then we'll check if temp2 is not equal to none. That is, temp2 is still having elements present. Then same thing, temp3 dot next will now store the pointer to current temp2. Now what do I need to return after all of this is done? Pointer to the head node.
Head of the merged list.
That is return head 3.
Okay.
Is this correct?
Yeah. Because we
So
are not
let's run it
modified.
once.
We are not
No,
modified
we
head
haven't
3
modified.
throughout the program. Only first.
See, head 3 is only modified in the first iteration.
First, okay.
Okay, only in the first iteration. In the if part, it is modified, nowhere else. Yeah, so all our test cases are passing. Okay, now you tell me which part you have a doubt in this code. Anyone has a doubt?
Ma'am, the
Very
only
yeah.
problem I had is when we read the question, it was very ambiguous, if at least for me.
Right.
It doesn't say that it has to be inline. I mean, it says
Right.
create a
So,
new list.
right.
Probably
So
if
here,
the same question would have got in exam, I would have created a completely third list, created a new
right.
list, but I don't know. It has
Let's
to be.
see where is in the question statement it is given. Write a function that should return. Okay. So you are given two lists with m nodes and sorted in ascending order. Your task is to merge these two sorted lists into one sorted linked list. Okay. So here nowhere it is specifically mentioned that whether it is an in place or not. That is whether we need to assign more space or not.
Yeah,
So in
it's,
OP, we'll be giving you specific
yeah,
instructions.
it's
Okay.
ambiguous. Okay, fine.
Also, ma'am,
Other,
also we don't know how to make a linked list on your, like we don't know the template of like linked list class. Yeah, how this linked list is made.
which one?
So, like in this question, if it is not mentioned, like we need to create a
Yeah.
new linked list.
No, you don't need to see. You only need to write the function. Okay, nothing else. All the
Yes,
prefix
ma'am.
suffix
That's
code that is hidden. Okay, and the node class is given to you. How that looks like. That's all. Okay, so
yes.
whatever happens, whatever the output linked list is, see this output code. These are all already taken care of in the suffix code. Okay. Any other doubt in this? Logically, it's clear. Okay. Let's do the last problem then. This is a very interesting and very important problem. Also, it comes a lot in your coding exams for companies when you go for placements, which is you have to create a stack using two queues. Right. So now no more linked list. You have to implement a stack using two queues. First, tell me what is the basic difference between stack and queue?
Stack is last in, first out. Queue is
No, first in, first out.
No, stack is LIFO, last in, first
LIFO,
out.
last in,
Right.
first out.
Queue is first in, first out.
First in, first
So
out.
just like stack means what? Like a stack of plates, right? So you're putting one plate on top of the other. So always you can remove the top plate first. That is the last plate that you put on the pile. That's the first one you will remove. And queue is just a line for, let's say you're trying to get tickets for your movie. There is a line. Who gets the ticket first? Who entered the line first, right? So first in, first out. That's your queue. Now you have two queues using which you have to implement a stack, right? And the implemented stack should support all the functions of a normal stack. In a normal stack, four things are there. Push means I am adding a new element to the stack. Where is the new element added? At the top of the stack, right? What is pop? You have to remove one element from the stack. Again, removal also happens from the top of the stack. What is top? Top is going to return the last element that has been inserted into the stack, which is the topmost element of the stack. And isEmpty is a function which is going to return true or false. It's a Boolean value. It will be returned. If the stack is empty, it's going to return true and false otherwise. Okay, so all of these four operations, yeah.
Ma'am, this difference between pop and top is pop actually removes the value. Top is
Yeah,
only
pop is,
returns a value but doesn't remove the. Okay.
No. Top will give you the top element. It will just
Okay.
return the top element.
Right. Okay, fine.
Okay. Now, so you have two queues. You have to implement these four functions and make it act as a stack. So here you can see the class queue and class stack are given. So in class queue, you can see the init function is forming a list. So obviously the queues are implemented using list, right? Enqueue is, where is it adding the new key? Enqueue means add a new key to the queue, right? That is the enqueue operation, and deleting a queue is dequeue operation. So where am I adding the key? First in, first out. So I need to add at which index? The first index, 0th index, right? So see items dot insert 0 comma key, that is insert the key at the 0th index. The new key is always going to be inserted at the first of the queue, front of the queue. And dequeue is doing what? It has to first in, first out, right? So where is it going to pop? It is going to pop the, what does pop operation do? Tell me. Pop
It removes
removes
the last element.
Last element of a list, right? So here we can see that in dequeue, the last element of the list will be removed. Okay. And in stack, we can see that we have two of these queues, Q1 and Q2, using which I'm implementing the stack. And there is also a size counter, which is initialized to 0. So this will keep track of how many elements are there in the stack. This will help us in creating the isEmpty procedure, right? Function. So we can check the size. If it's 0, we can return true. If it's not 0, we can return stack is not empty. Okay. Now this part is just to take input of what you want to enter into the stack. Okay. So we have to deal with what? We have to create these four: push, pop, top, and isEmpty. These four functions. So you tell me what is the solution that is coming to mind. For isEmpty, I already told you we will take care of that using the size. that if the size is 0, it is true, it is empty, otherwise false. Now you tell me for top. For top, how do I know which is the topmost element? That, see, in queue you can only insert from the front of the queue, right? So here we have two queues, Q1 and Q2. So what we are doing is, whenever we first push an element, okay, we are going to use both the queues. So whenever you first push an element into the queue, let's say I am first pushing into Q2. Okay. Let me again do a dry run before we write the code.
But why two queues, ma'am? Here, when
This problem is that you have to create a stack using two queues. That's it.
okay.
Okay. So Q1 I have and Q2 I have. So first, what am I going to do? In Q2, I'm going to enter the new data. Let's say this is the data I want to enter: 10, 20, 30, 40, 50. In this exact order. Okay. Just
What
give
is
me
the, yeah,
just give me a 1 minute. I'll be
sure,
back.
sure.
Yeah. Okay. So we want to insert in this order. Okay. First, we are inserting the element 10, then 20, then 30, then 40, then 50. Okay. So at the end of pushing all of these elements, 50 should be your top element in the stack. Fine. But we are implementing it using queues. So first thing we are going to do is the push operation when we do push. Okay. So let me explain push, how it will work. We have to use both the queues in order to push it in the correct way. So as soon as you push an element, size has to increase. So size will be plus equal to 1, right? Because one more element is now added. Size is the counter of how many elements are there in the current step. Now first you will enqueue this data into Q2. So Q1, Q2 are initially both empty, right? Now you enqueue data. It is at index 0. So what is the first data I am pushing? 10. So now Q2 contains 10. Q1 is empty. Okay. Now I'll run a while loop. Okay. This is the tricky part. I'll run a while loop where I will check that self dot q1 dot items is non-empty. That is, as long as q1 is non-empty, this loop will run, and what it will do is self dot q2 dot enqueue. What will I enqueue? Self dot q1 dot dequeue. Okay. Now why am I doing this? See, I have to do a swap between Q1 and Q2 every time I push a new element. So after this loop runs, what will happen? Self dot q is a variable in which I'm going to first store Q1, self dot Q1. This is just a swap. Okay, and then in self dot Q1, I'm going to store self dot Q2. You all know three variable sorts, right? How to swap values of two variables using three variables. If I want to swap A and B, I'm using a third variable C. So this third variable is Q. And lastly, self dot Q2 is storing whatever is stored in self dot Q. So why am I doing all this? First I entered 10, right? Q2 now has 10, Q1 is empty. So will the while loop work if Q1 is empty?
No, it's not.
No,
It's equating to checking for empty.
right? But it will still do the swapping. So at the end of swapping, Q1 will contain what? The list containing item 10. Q2 will contain what? Empty list. The lists are swapped. See, Q1 is stored in Q, then Q1 is stored in Q2, and Q2 is storing whatever is stored in Q, which is the contents of Q1. So after this, Q1 and Q2 are now swapped. Now we have to push the second element, that is 20. At this point, remember, Q1 is containing 10, Q2 is empty, right? So now if I push 20, so now Q2 contains 20. Now again check the while loop. Will it run? Is Q1 dot items non-empty or empty? Is Q1 contain?
Non-empty. It's true.
It has an element, so it's
Yeah.
non-empty. So what am I doing first? DQ Q1. DQ takes out what? Pop. That is last element of the list is popped. Right? That is the DQ procedure. So there is only one element, so 10 will be popped from Q1. And this 10 that is popped is now enqueued in Q2. So now Q1 becomes empty since 10 is popped. Q2 becomes what? Where will this 10 be enqueued in Q2? The new key is always pushed in the 0th index. That means now Q2 looks like 10, 20. Is this correct?
Okay. Yeah.
Okay. Now you do the swap again. This swap will happen in every iteration. Okay. So now at this point, if I swap Q1 and Q2, now Q1 contains 10 and 20 in this order, and Q2 is again an empty list. Next element I want to push is 30. Okay, and always I'm pushing the element into Q2 first. So at this point, Q2 is empty, right? And Q1 contains 10 and 20. So push 30 into Q2. Q2 contains 30. Is the while loop going to run? There are elements in Q1. Yes. Which element will be popped first, 10 or 20? DQ, when I do DQ, it pops the last element of the list. Since it uses the pop function, which pops the last element of the list. So which element will be popped from Q1 first, 10 or 20? 20. And that will be enqueued where? In Q2, which now currently contains 30. So now after the pop, Q1 will contain 10, and the 20 that has been popped is entered in which index in Q2? 0th index. So
Yes.
this will look like 10, 20, 30. One more iteration of the while loop will happen since there are still items in Q1. So now this 10 is popped. Q1 is now empty. Q2, this 10 is going to be enqueued where? In the 0th index. So now Q2 looks like 10, 20, 30. Again do a swap. Now Q1 is, this while loop is now over since there are no more elements in Q1. So now you swap Q1 and Q2. So Q1 now contains 10, 20, 30 and Q2 contains empty list. Similarly, you will enter 40 and 50. Okay. Now see, this, after all of this is done, right? Q2 at the end, after I have pushed 50 and the swap is over, all the elements of the stack are present in Q1 or Q2 after the swap? In Q1, right? Q2 is always swapped out for the empty list. So it is 10, 20, 30, 40, 50 all stored in Q1, and Q2 at the end of all the pushes is still going to be empty. Okay, so we are just using Q2 in order to push the elements into the right index, right? So that we can always push the last element first. See, this is the stack order, right? Always the new element should go to the top of the stack. Now, once this is created, now if I ask you, what will be the top of the stack? So if we define that function top, and it takes the stack or just let's say the self object. So we have the stack stored in Q1. So what is the top of the stack? The last element we entered, which is 50. So first you have to check if the stack is empty or not empty. If it is not empty, only then it will contain a top. So if not self dot is empty, then return self dot Q1 dot items, that is the list, last index -1. Is this the top? 50. This is Q1 last index. Is this the top or not?
Yeah, ma'am. Can you go back, ma'am? Let me see the original array. Okay. It's exactly, ultimately with all this procedure, we end up with same 10, 20, 30, 40, 50.
Yeah,
So,
but we are trying to create it in a stack. Okay, these 10, 20 elements you are going to insert, like the user is going to give these inputs, but the
okay.
stack is being created using these two queues.
Okay.
Okay. So this is the top, and the push functions now are clear to us. So if the list is empty, in that case you can just in the else part return that stack is empty. Right. Now what other functions are there? Is empty we are not doing, because is empty is just that size. We have to check if it is 0 or not. That's it. So what is left? Pop. So we have to define the pop function. Now in the pop function, what is the rule of stack? Last in, first out. So which element after this entire stack is created, which element should be popped first? 50 or 10?
50.
50, right? That is the top element. So in pop, we are going to first check if, again check if the stack is empty or not empty. Only then you can pop. In an empty stack, you cannot pop. So if not self dot is empty, that is there are elements in the stack, then first decrement the counter. Self dot size minus equal to 1 and return. So can I use DQ operation here in Q1 to pop? DQ operation uses which function? Pop function, which pops the last element of a list, which is the top element here. So can I directly return self dot q1 dot dq? In pop, you just have to remove the element. You don't have to return anything. So I'm just performing a dq on q1. So if I do a dq on q1, 50 will be removed, which is the top element. So this is a correct pop operation for stack, right? Last in, first out. 50 was last inserted, it is first removed. And again, in the else part, if it is an empty stack, then you will just write stack is empty. So all four operations are clear. See, the main thing of how you are attempting to get the stack out of two queues is in the push operation, right? This swapping that we are doing, this is the main thing. Why we are doing this? See, every time a new element is being inserted, our job is to make sure that that new element stays in the last of the list, right? Last index of the list. So that when we pop, that will be the final element that is popped. That last element is the top element that needs to be popped. If we normally enqueue elements into a queue, elements are going to be enqueued from the beginning, front of the queue, right? If instead of doing all of this in the empty queue, Q2, if I enqueued all of the elements one by one, will it not look like this 50, 40, 30, 20, 10? Right? Since in enqueue operation, we saw that the queue is always inserted in 0th index, new key. So it would look like this, right? And now if I do pop, it is not removing the last inserted element, which is 50. It will remove the last element of the list, which is 10. This becomes first in, first out. We are trying to implement stack last in, first out. Okay, that's why all of this is done in the push operation. Is it clear? Should we write the code? Yes, any doubt?
Ma'am, so theoretically this is okay, but from the actual practical application, I don't understand why we have to go through this complex 2Q process, because
No, see, it is
create,
not required, obviously.
yeah, we
It is just a problem that has been created to
okay.
see if you can implement a stack using two queues.
Okay,
Obviously, stack is already there as a data structure. Why will we use two queues?
No, it is there. Even if a single queue, you have to just keep appending to the last for the push, and pop you just extract last.
No, see, the thing is, in a queue, the operation is always going to be FIFO.
Yeah.
Okay, so in a single queue, you cannot implement stack. You need at least two queues to implement a stack. To make it LIFO, we have to do this swapping. Otherwise, the recently inserted elements will always be in the front of the queue. The top will always be at the front of the queue. So you cannot pop it. Pop will only remove the last element in the queue. The recent element, if it stays at the front of the queue, we cannot pop it. Right?
No, if you can maintain, if you can maintain a head and a tail, two parameters, head and tail. So always push goes with tail plus 1, and pop tail is a pop and tail minus 1 will be the
Now,
next.
if you want to incorporate pointers in it,
Huh.
then you might be able to do it.
Okay. Right. I'm just thinking why such a complex system. Right.
No, it
Thanks.
is because this is a very famous problem. Okay, this has come
Okay.
multiple times, that how to
Sure.
implement a stack using two queues.
Okay. Thank you.
So let's now start writing the code. We have to write 4 function definitions. Okay, let's write the simplest one first, that is empty. So def is empty. It takes what? Self. No parameters are required. So what we do here is we check the size counter. So if size is 0, just return that. So we have to return a boolean value, true or false, right? So write return, if not self dot, I'm sorry, we can directly write a return statement here. Return self dot size equal to 0. So if size is 0, it will return true or false, otherwise, right? Nothing else required in this is empty procedure. Next, we'll write how to find the top. Okay. Do you want to write that first, or should we write the push function first? I think push is better. Then the top becomes easier to understand. So push will take what? The data we want to push. So self comma data is the new data I want to push into my stack. So first thing we do is increment the size. Every time we enter a new data, we increment size. So self dot size will be plus equal to 1. Okay, after that, so tell me first in which queue did I do the enqueue? In Q2. Self dot Q2 dot enqueue. Pass the data parameter. Next, you check if Q1 has any items in it or not. So the while loop comes here. So while self dot Q1 dot items is not equal to an empty list. Okay. Then what will we do? If it is containing elements, if Q1 is containing elements, then we have to dequeue them one by one and enqueue them into Q2, right, before we do the swapping. So here we'll write self dot Q2. So in Q2 we will enqueue what? Enqueue whatever we dequeue from Q1. So self dot Q1 dot dequeue. Dequeue is just a simple pop operation that removes the last element of a list. Okay, this is all you need to do inside the while loop as long as Q1 contains more items. Once Q1 is exhausted, Q1 is empty, all the elements are in Q2. Now we do the swap. Right, so self dot Q is the 3 element swap. Self dot Q first contains Q1, then self dot Q1 will store self dot Q2, and lastly self dot Q2 will store self dot Q. So now the swapping is done. So this is your push operation. Okay. Now we can write the top. So you saw in the dry run that ultimately all of the elements are stored in Q1 or Q2 after all the elements have been pushed in Q1. Right. Q2 is always swapped into being an empty list. Initially all the elements are enqueued into Q2, but then we do the swap to get them back into Q1. So now when I do top, so this also doesn't take any separate parameter. We will check if the stack is empty or not. So if not self dot is empty, that is if there are elements in my stack, then I can return. So top function has to return the top element. So that is self dot Q1 dot items. Which element I have to return? The last element. So index for that is -1. Right. And if your stack is empty, in that case just put a else statement, and here you can write return stack is empty. So what is left now is empty, push, top, all are done. Now we have to do the pop operation. The pop function is left. So def pop, this also doesn't take any separate parameter. This doesn't need to return anything also, it just needs to dequeue or pop the top element of that stack. So again you check if stack is empty or not empty. So if not self dot is empty, that is if there are elements in my stack, then the size will be decremented since I am now going to pop an element. So self dot size minus equal to 1. Okay, and after that now actually dequeue the element. So return self dot q1 dot dequeue. This will pop the last element from q1, which is the most recently added element. And if your stack is empty, in that case, in else part, just write return stack is empty. So all four procedures are clear for everyone. Any doubt? This will take some getting used to, so you can do a few more dry runs.
We have to do ourselves, then only we'll get some.
Yeah. See, let's still do a test run and see if it's running.
But in the exam, it will be taking a lot of time to really repeat.
Yeah, that's why wait, something is wrong. Stack object has no attribute push. Okay, so okay, again the same thing. We have to just put all of this. Yeah, see, in the exam we usually don't give this type of questions, okay, which are very time consuming.
Okay.
In exams, these are very famous problems. That's why we are discussing them, so that in placements it will help. Okay.
Sure.
But these are not exam related questions. In exam, you'll get more questions from linked list part.
Okay.
Okay, let's quickly do this. In next week onwards, I think I think the linked list part is over from next week onwards, right? So this week you already had the open session, right?
Yes,
that is all the topics have been discussed.
Yesterday we had one open session.
Okay. So after this you can give all the programming assignments. Is this indentation correct?
Can we assume that these are the precursor to the OP exam?
Definitely. See, OP exam is going to have very similar kind of questions that we discuss in the live coding session.
Okay.
Okay, so this is return and else part. Now let's try. I think it's some kind of indentation error only happening. Can you see an indentation error here? Line 39, module A1, line 17 and push. This one. No, this is correct indentation only. Where is the error happening? In any case, this is just an indentation error, but we need to solve it. All the indents look correct only, right?
Yes, ma'am. Line 17, I don't see any problem in 17.
But that's the issue. Expected output, okay. Oh, some kind of indentation error is there. In the class stack only we have implemented all of this. So that's fine. This is also fine. Line 17, I don't see any error. Then no issue. See, you can just take this code and copy paste in your editor and see if it is running. Keep the indentation same. Can any of you just check? It should run. I mean, logic wise, it is all correct. There is some kind of an indentation error I cannot see.
No, we cannot copy this one from the screen.
I can copy paste it in the G chat. You take it from there. Okay. Okay. Yeah, I've given it. And just check once if it's running for you. In the self part, is the error coming? Let's check. The self.q, this one. There's nothing. You just have to press enter and check for all of the lines where the indentation is wrong. Okay. If it's running for anyone, you can tell me.
I guess in line 17 you need to write self.q1.
Which line?
Line 17.
No, this is self.size, right? Oh,
No,
here
I mean
I
self.
added a
Ah,
Q. Okay, that was the mistake.
Yeah.
Let's see now. No, still there is something wrong. But it is not even showing the actual output. Self.size plus equal to 1. This is fine. Is the test run not happening properly? Is it running for any of you? Did you try with the code? Because now I can't even see an error message. But the code itself is correct. I don't see any other problem. Self.size here also one we have used. Not is empty. Size is 0. Return def push. It's not self empty. No, I don't see any other mistakes. There is no error coming. How will I know in which line the error is? Is there something wrong with the back end of this problem, or did anyone try with the code I pasted? Let's try once so that we can be sure that if it is just an error on my side or the code itself, something is wrong.
It's showing a blank out.
Okay, so why that is? That's what, because we don't have to do anything else here. The print statement and all of that is covered in the suffix code, so we just have to write these 4. Okay, let me check one more time. Is empty function is correct. Self.size equal to 0. Push self data. Self.size plus equal to 1 NQ data while self.q1 items not empty list. Self q1 dq. No, this looks fine. Here the problem is In Q2, I had to store Q, right?
Chat.q is
Yeah.
slow.
Yeah, now it's working. Okay. Okay, so these are the 4 problems for this week. If you want, I can give you the codes. You can ask on Discourse. I'll give you the code then. Okay, do you have any doubt in any of these 4 problems? Anyone?
No, ma'am. We
Okay.
have to try ourselves. I think that's the
Yeah,
key.
right. You have to try yourself. Don't look at the code, write it on your own.
Yeah, yeah. And
Okay,
then
but
compare the code.
yes, if you want, you can either watch this session also, or you can ask me. I will share the code on Discourse.
Okay, ma'am. Ma'am, this
Okay.
difference, what is the difference between this live code session, live coding sessions and this lead code, ma'am? How are these
No, these
different?
live coding sessions are just for OP practice and for
OP
the
practice.
graded
Okay.
assignments.
Okay, ma'am.
Yeah,
The
graded programming assignments.
the
Lead
another
code
session.
is more for competitive programming.
Oh, okay.
Okay. Yeah. All right. Thanks everyone. Thanks for joining. Have a good
Okay,
night.
ma'am. Thank you
Hello,
very
ma'am.
much, ma'am.
Hello, ma'am.
I think she left for the day.
Yeah. No.
Oh,
Yeah.
okay.
What are you saying?